Hey everyone, welcome to day 1 of Project-Oriented Python. Hopefully you followed day 0. If you did, you should recognize what you're looking at right now. If you didn't, please go back to day 0, finish day 0, and make sure you get to this page. You should have your server running on the left here. You should be able to see the Django site over here. I'm going to pick up right from the end of the day 0 tutorial. And what I'm going to do here is I'm going to kind of walk through the day 1 step by step. So this is going to be a step-by-step guide. But what I'm going to try to do is highlight some of the errors that I think you'll hit along the way. So if I think of something that I typically see where somebody makes a mistake, I'm going to try to call that out. So let's go ahead and get started. The first thing I'm going to do, I'm ending day 0 right here, is I'm going to press Control-C on the keyboard to stop my server from running. If I try to refresh the page now, you're going to notice nothing is going to work. So we've officially stopped the server. Now in day 0, we got your Django project configured, but we didn't really learn any Python. And that's what we're going to focus on day 1. We're going to actually learn some Python basics, because before we can do anything web related, we kind of have to establish some Python basics, especially if you're not familiar with programming, even if you are, especially if you're not familiar with Python itself. So the first thing we're going to talk about is the interactive Python prompt. So I'm going to look over to the right here because I have the docs pulled up on the right. So when you see me like glancing over here, it's because I'm following my own documentation to try to keep up with it. So first things first, you've got your terminal in VS Code. It is super important that you have a venv to the left of the terminal. And I call that out the first thing in the docs because this signifies you're working in your Python virtual environment. What does that mean? That means that inside VS Code, there's this folder called venv, and it has all of your Python stuff. This includes the Python executable, but it also includes all of the packages that you installed. And this includes things like, for example, pip and ASGIREF and Django. These are important things that you need. If you don't see this, you're going to hear me say this over and over again. I'm going to ask you to source your venv. What does that mean? That means that you're going to either on Windows type venv scripts activate and press enter. And if you do that on Windows, you'll notice, there we go, got our nice little thing there. In fact, I can deactivate mine. Okay, clear my terminal. So I'm going to say venv scripts activate. Okay, there you go, got that back. And if you're on Mac or Linux, you're going to type venv/bin/activate. Oops, sorry. You're going to type source venv bin activate. And that will do the same thing. It'll put the parentheses there to the left of our terminal cursor. So with our venv activated, let's go ahead and get started. We're going to start by talking about the Python prompt. Now, if you've worked with programming languages before, some of them have this. Really, really useful. But I know that there are some things where it just isn't built in. So for example, Java. Java doesn't have this built in. C++ doesn't have this built in. So Python ships with what's called an interactive prompt. If we just type Python into the console and press enter, we're going to come up with these 3 kind of right arrow things. This is really cool. We can type any Python code we want into this prompt, and it will execute for us and show us the results. So we don't need to do any printing. We don't need to do any debugging. You know, we can literally do like 1 + 1, 2. There we get an output. And that's actually the first thing I have us do is just press 1 + 1 and press enter. So the cool thing is this functions as a calculator. You need a calculator, you can pop open VS Code and do some math. But let's go ahead and keep going. So the next thing I'm going to have us do is assign 1 to a variable. So x = 1. If you've worked with programming before, this should look very familiar. The one thing that might be missing that you might immediately recognize is we're not giving x a type. So for those of you who are familiar with typed programming languages, we're not saying like, hey, x is an integer or x is a string. We're just saying x = 1. So Python is called, it's called duck typing, but it's dynamic typing, where Python will interpret the value of x based on what's assigned to it. And that's pretty cool. We're going to get more into that in a second. But basically, you can assign something to a variable without giving it a type. The next thing we're going to do is just press X and press enter. So this is one of the things that you're going to find most useful is when you're working in the Python prompt here. If you want to print something or you want to see the value of something, again, you don't have to like print X. I mean, you could do that, but you can just press X and press enter. That's going to give you the value of whatever we're looking at. It goes for any variable or any function. Next thing we're going to do is we're going to add 1 to x. Variables work exactly the same way as their number counterparts. So if you're not familiar with programming, all I've done here is said x, x, which has the value of 1, add 1 to it. And it should do exactly what we expect it to, which is adding 1 to 1. We're going to get 2. Same thing. The next thing we're going to do is just assign x to 3. Notice how when I'm assigning to Python in the interpreter, nothing returns. We only get returns back when I type x and press enter separately. That's intentional. You're never going to see a return if you assign something. So we've reassigned x to 3. X is not 1 anymore. So again, press x, I get 3. If I do x plus 1, we're going to get 4. So x is now 3. Next thing we're going to do is we're going to type x equals hello. So assigning numbers to variables, if you've taken a math class, that should make some sense to you. But assigning strings to a variable, if you haven't done programming, might not make a lot of sense to you. Also, if you have done programming before and you're used to a typed language, assigning a string to a variable that was previously a number might seem a little strange. So again, Python variables don't take a type, and Python has no problem assigning whatever type you want to your Python variable. That means that I can set x to a string, and if I type x, press enter, I'm going to get string hello. I can use the type function to see what type x is. You'll notice it's a string. And then if I set x back to 3 and type x, it's going to be an int now. So Python will happily flip x from an integer to a string, back to an integer, to whatever you want it to be. Python just works like that. So I'm going to reassign x to hello. And the next thing we're going to do, if I check my notes, is give myself a name. All right, so x, it's a great variable. Don't get me wrong. I love x. The problem with x is I have no idea what it means. When you're programming in general, you want to try to give your variables names that signify what they might be. I have no idea what x is. I mean, maybe a coordinate. If you're working in a coordinate plane, yeah, x is a great name. But otherwise, x is terrible. So let's go ahead and do that now. I'm going to say my underscore name equals Reese. That's my name. Hi. My name is a much more descriptive variable. And that's going to help us when we're writing more complicated code, because as we're scrolling through your thousands and thousands and thousands of lines of Python, when we come across a variable like my name, we know that should be my name. Next thing we're going to do is just press type my name and press enter. And again, we can just type that, press enter. We're going to get the output. So my name is Reese, and that's the value that gets stored in it. Okay. We're going to move on to something a little different now. So we've worked with variables that hold one thing. So x held one number or one string, and my name held one string. But what if we need more than one piece of data and we want to keep it stored in a variable? You can think of this like a shopping list. You wouldn't take a sticky note for every item on your shopping list and go to the grocery store with 20 sticky notes. You would probably put it on a list. And Python has much the same thing as a list. So we're going to start with what's called a tuple. I started with a tuple because I think for those of you who are familiar with math and other programming languages, this will make a ton of sense. So let's start with my coordinates. All right, so what I'm going to do is I'm going to say my coordinates equals 1, 2. So if you're familiar with your xy plane, that would be x equals 1, y equals 2. I'm going to press enter. Now, I like this in Python because when you're doing this in math in high school, this is what it looks like when you write it on your math test. And I don't remember most of what I learned in high school math, but I do remember that this is what a coordinate looks like. And that makes it super helpful because I can say my coordinates equals, oh, look, it looks exactly the same in Python as it would if I were to write it down myself. If I type my coordinates and press enter, I'm going to get back exactly what I typed. It just adds a little space for some formatting. And that's nice. So that's, typed it, and it returns exactly how I typed it. Notice how we've got a comma in here, we've got parentheses in here. There's a lot more going on. So up here we just had quotes, And when we did a number, it just returned a number. But this is a special type of thing. This is called a tuple, and it stores a lot of items in it. So let's use another example of a tuple. So another thing that you might want to store lots of items in is an address, because an address is going to have multiple parts to it, but each part means something different. So you might not want to write the address down as a long string, because maybe you want to validate the street number, for example. If you write it down as like a long string, how do you validate just the street number? You're going to have to extract it somehow. So instead, what we can do is we can say, all right, my address is 123, comma, Lane Avenue, comma, Columbus, comma, Ohio, oops, comma, 43212. So I've added 5 parts to my tuple. And this is important because we can essentially store as many items as we want in here and then access them whenever we need to. You'll notice, by the way, that I was able to mix integers and strings inside a list. For those of you who have done more traditional programming languages, this will also look weird. So in Java, for example, you have to say, I want a list of strings. And you can't put anything else in that list except strings. But what we've done here is said, yeah, I'm just going to put everything. You know, we've got some integers, we've got some strings, and we got another integer at the end there. Python doesn't care. So feel free to put whatever you want, mix and match. It's all good. I'm going to press enter. I'm going to type address and press enter so you can see that print back out. And you'll notice that because of the way I've typed it up here with my nice spacing, the way it gets printed out is exactly the same. And that's pretty cool. The next thing I'm going to do is I'm going to use what's called the len function, L-E-N. This gives us the length of things that are longer than 1. So you can't do this, for example, len 1. An integer object has no length because it is just one thing. However, I can do len hello, because a string is technically multiple letters, and it will count each letter. So I've got 5 characters or letters in the word hello. So len will just tell us how many things there are in our data. So if I type len address, I'm going to get 5 things back, because we have 5 items that we stored in address. Next thing we're going to do is access those items within address. So remember I said the nice thing about a tuple is that we can access, for example, the street number. Whereas with a string, we'd have a really hard time getting the street number back. So I'll make this clear. I don't do this in the tutorial, but I'll make it really clear here. So let's do address 2 equals 123 Lane Avenue, Columbus, Ohio, 43212. So you'll see here I used quotes, and I typed the entire thing inside these quotes. When I press enter, and I type address 2, it's one big thing. If I type len address 2, there are 30 characters in it. The problem is, how do I know which of these items is the street? I might be able to write something that says, okay, well, the first X numbers is the street number, and then the next, few characters is the street name, and then, well, maybe I can have a list of cities, but already we're way too complicated here. In reality, this isn't a good way to store an address. What we want to do is use our tuple, because I can say address at 0. So when I say at, by the way, I mean using these square brackets to denote a position in the tuple. These square brackets are important because any list-like item supports these brackets. So when I press address at 0, I'm going to get back the first item in our address list. When we entered it up here, it was 123, comma, so the first item is 123. For those of you who have done programming, you'll remember that all lists, tuples, etc. start at 0. So we count up from 0. The 0th item is the first item. If If you haven't done a lot of programming, maybe you haven't gotten to that point yet, just know that if you do address at 1, so if you think, oh, I'll get the first item in the address, I'll put a 1 there, you're going to get the second item. That will mess with you. That also means that the last item is not the length of the list. So a lot of people, when they start programming, are going to make this mistake where they say, okay, so I want to get the last item in our list. I'm just going to get address at 5 because I know there are 5 items in it. Oh, no. We're going to get a tuple index out of range error. So remember, your address or any of your tuple or lists, they always start with an index of 0. Okay, so the next thing we're going to do is just keep accessing some of our items. So I showed you address at 0. Now we're going to get address at 1, and address at 1 gets us the second item. I did that up here as well. So you can see, yep, Lane Avenue, when we entered that data, that was the second piece of data we entered. Therefore, it is the first index. So 1 is its index. Okay, so the next thing we're going to do is we're going to create a dictionary. So we've worked with a tuple, and tuples are great because we can store multiple items in a list format. So an example of when you might want to use a tuple might be a grocery list. Literally, you want to store what items you need to buy, or think about setting a list of reminders. It's just a list. There's no there's no name for any of these things. So if I'm making a grocery list and I want to put, apple, banana, pear on my grocery list, there's no label for an apple, right? An apple is just something you buy. But think about an address for a second. As if we talk about an address, what is 123? The label for 123 is like street number. So it has a label. In this case, Lane Avenue might be a street. That might be its label. So there are instances where we want to describe things more than just putting them in a list. That's where dictionaries come in. So dictionaries are really cool. So I'm on step 19, and I'm just going to go ahead and copy the dictionary example that I have here and press enter. And it's a bit messy, but I'll walk you through some of what's going on. So we've created this dictionary called vocabulary, just like we created this address called address. And what we're doing in vocabulary is we're creating basically a word and its definition. So the word is going to be apple. The definition is going to be the usually round, red, or yellow edible fruit of a small tree, Malus sylvestris of the rose family. Okay, so the cool thing is these dictionary definitions mean something only when they're paired with their label. So when I was talking about labels before, this is kind of what I was referring to. We wouldn't put a bunch of dictionary definitions in a list. They wouldn't mean anything. We wouldn't, what's the second dictionary definition? It's not going to mean anything unless I give you a word. And that's what a dictionary does. And a dictionary lets us access items in a similar way to a list, but using these labels that we've created. So if I type, I'm on line 21 here. I'm going to go ahead and skip 20. You can type vocabulary and press enter and see what comes out. So if I do vocabulary at apple and press enter, I get back our definition. So for literal dictionaries where we're defining a word, accessing a value or a definition at a particular label or word instead of an index is really important. Not just for syntax, but for human readability, because this makes sense to me. Whereas if you just throw the definition of apple, as your 6,324th item in your list, that's not helpful to me. I'm not going to be able to figure that one out. But I can figure out what it means if you let me access it as an apple. All right. You have a little bit of a briefer on some Python stuff, but at this point, we're going to move to some things that are too complicated for the interpreter. So we're going to go ahead and type exit and press enter to exit the interpreter. The biggest problem I see when people are starting out is they forget to exit the interpreter. So let me show you what's going to happen here, right? So you're still in the interpreter and you've got 3 little carrots here to the left. And you're going to try to do something. You're going to try to run something. So let's do, Python my program.py. You're going to press enter and you're going to be like, syntax error? What do you mean? I'm running exactly what you're telling me to run. No, you're still in the interpreter. You can't do anything in the interpreter. You got to exit. Always be exiting. You can even be super safe because once you exit the interpreter, you can type that too, and boom, your terminal goes away. You can open up your terminal and you're in a fresh one. So that's how you're going to do it. Make sure you're out of the Python interpreter before proceeding to the next section. Welcome back, everyone, to part 2. This is picking up right after we left off after part 1. We're going to be in the section called a Python program, if you're following along in the docs. So we've got a little Python experience under our belts. We can do some stuff in the Python interpreter, but like I said last time, in order to write anything more complicated than a few lines, we need to take it to a file level. So we need somewhere where we can actually write a few more lines of Python code, save it, and execute it repeatedly. And that's what we're going to do during this part. So the first thing I want everyone to do is make a new file and call it my_program.py. If you're using VS Code with the default icon pack, you'll see that it changes to a little Python icon. So you'll know this is a Python file with the Python extension. And in here, we're going to start writing some code. So the first thing I have you do in instruction number 2 is I say print hello world. There we go. And save. The next thing that I'm going to have you do is run this program. So down here, again, make sure that your venv is sourced. I recorded these at different times, so to resource my venv, there we go. Got my parentheses venv on the left. I'm going to run Python myprogram.py, press enter, and voila. We have hello world printing to our screen. So that's all exciting, but this is something we could have done in the interpreter. Let's get a little more complicated. By adding a second print line. Print goodbye. So now we're executing multiple things in a row. When I run Python myprogram.py, it's going to run this print statement, line 1 first, hello, world. And then the next thing it's going to do is run print goodbye. You'll notice I can have as much white space I want in between all of these programs. So I can do this. Don't know why I'd want to, but as much white space as I want. Run that again. There we go. Prints the same thing. Or as little white space as I want. I can run this and it'll work just fine. There you go. Just make sure that these are return separated. I like to keep a space between different lines that are executing. So one of the most common things I see that drives me nuts is when people write all of their Python code right next to each other. And you're like, well, why did you put all this together? Wouldn't it be so much more readable if we could separate these things out into the chunks that they're supposed to be logically? So keep an eye out for that. I like to put some spaces. That's just how I like to program. Put some comments in there to help separate things out. It just makes it easier to read your code. So we printed hello. We've printed goodbye. Let's do some more stuff. So below print goodbye, I'm going to type x equals 1. That should be familiar. Y equals 2. I'm going to do print x plus y. I'm going to do my name equals Reese. And then I'm going to print my name. I'm going to save that, and then I'm going to run it down here. And we've got all of our code executing in order. I'm going to pause here for a second and point something out I don't point out in the docs. When we were in the Python interpreter, all we had to do to get something to print to the screen was type it and press enter, and it would print out for us. When we're working in a Python file and we run it using Python, if we don't specify print, nothing will show up. So let me show you what I mean. If I run Python myprogram.py right now, all I've done is I've commented out the lines that I don't want to execute. So I'm not going to run any of these print statements. So a hash sign in Python is a comment, and anything that comes after a hash sign will not execute. So the only code that's being executed is x equals 1, y equals 2, and my name equals Reese. So if I run this, here we go. Nothing's going to print. More importantly, if I do this, if I just type x, so remember in the interpreter, we're able to type x and press enter, and it would print. If I try to do that in here, nothing's going to happen. It's not going to throw an error. There's nothing wrong with just having, an x floating there. That's fine. But nothing will print. So if you're confused about why things aren't printing to the terminal, make sure you're actually printing them. Going to uncomment this stuff. For those of you out there who like keyboard shortcuts, by the way, and you want to quickly comment something out, Control / in VS Code will comment and uncomment the line that you have selected. We'll also do big block comments like that if you want to. Useful tidbit if you're commenting lots of things out. Here's the next problem. So we have all our stuff printing out, and I would argue there are kind of 3 parts to this code, right? So there's the hello world, which is the start of the code. There's the goodbye. Kind of want the goodbye to go at the end. And then we're doing some stuff here. We got X, we got Y, we're printing X plus Y. We're getting a name and we're printing my name. So I would consider each of these to probably be a block of code. So let's logically separate these blocks of code so we can choose the order we want to execute them in. Because right now, they're only ever going to execute in one order. It's going to execute this first, this next, and all of this last. Let's fix that. We're going to build what's called a function. So functions in Python, if you worked in other programming languages, you'll know what this is, but functions in Python look like this. We use the keyword def. Def is short for define. So we define function, and then we have to give it a name. We're going to call our function print hello. You name functions in the same way that you would name a variable. So notice how we say my name equals Reese. Here we're just saying def print hello. Then we're going to put some parentheses after it. Now, if you remember from part 1, parentheses mean something. Parentheses are tuples. And so one of the ways you can kind of think about functions in a roundabout way is it's the name of the function, so it's a name that you've given it, followed by a tuple. And tuples can hold lots of stuff. So I can put lots of things in a tuple. And those things in the tuple will be accessible underneath our function. We're going to talk a lot about that later, but just know that it's just a tuple after a function name. So we've given our block of code here, print hello world, we've given it a name. We can now call print hello, and it will print hello world. So we're going to run our program, Python myprogram.py, and we've got our self-printing. Oh, wait a minute. We don't have our self-printing hello world. Ah, interesting. What's going on here? Well, what happened was we built a function that calls print hello world, but that takes this line kind of out of the execution. So Python's going to go line by line through your script, and it's going to execute in order. So we're going to say def hello world. Then we're going to say, all right, so one, we're defining a function. And then Python's going to go, well, what goes inside that function? Line 2. All right, this is what goes inside this function. Okay, we're not running what's inside the function. Python's just learning what's inside the function first. Then we're going to go to line 3. Okay, there's nothing there. 4, nothing there. Line 5, print goodbye. Ah, that's something I can execute. Because print, much like print hello, is just a function. And we're going to print goodbye. Line 6, nothing there. All right, so then we're going to assign some variables. Ah, another function I can execute. Print x plus y. So we're going to do something there. Then we're going to, my name, and then we're going to, oh, there's another print function. We're going to do something there again. So we're calling the print function at this kind of like, no indent area. But in here, we're not calling print hello yet. We're just printing hello. So what can we do to fix that? Well, we can call print hello in the same way we called print goodbye. But we're going to get to that in a second. Let's go ahead and finish modifying our code here. So the next thing we're going to do is we're going to build a def print goodbye function. We're going to indent that. All right, so now we got our block of code executing under print goodbye. And then down here, we're going to build a function called, middle stuff. All right, so everything underneath middle stuff is going to run. And this is a good example, because up until this point, we've only had one line of code that was executing underneath a function name, but anything that's indented with 4 spaces underneath this function will execute in the same way, in the same, order as it would have if it were not underneath a function. So we have 3 functions. Now, again, if I call, I have to save. If I call python myprogram.py right now, nothing's going to happen because we're not executing any of those functions. So another really common place where I see people mess up is they'll build a function and they're working in a script, and then they can't figure out why none of the code that's in their function is running. Well, it's because you're not executing any of that code. You wrote the function, and that's great, but you never called the function. You never used it. So that's the next thing we're going to do. And remember, part of what I said before was we wanted to reorder this stuff because we wanted hello world to be first, we wanted goodbye to be last, and we want this middle stuff to be in the middle. And previously, to do that, we would have had to physically move our code around. But check this out. Watch what we can do now. I can say print hello. Print hello. I can say middle stuff. There we go. And then print goodbye. And so Python's going to go through and see, all right, so for line 1, we're defining something. There it is. There's the code that executes under there. Line 4, all right, we're defining something again. I'm learning what's under here. Line 7, I'm defining something. I'm learning what's under here. Line 14, we're doing something. And Python's going to see print hello, and it's going to go, well, do I know what print hello is supposed to do? I do. On line 1, I learned exactly what print hello was supposed to do. It's supposed to print hello world. And so Python goes, I know that one. I can execute it. Print hello. Then Python goes, do I know what middle stuff is supposed to do? I do know what middle stuff is supposed to do. I learned it up here in line 7. There's all the code that's supposed to execute under middle stuff. And print goodbye works the same way. Do I know what print goodbye does? Look at that. Yeah, right there. Print goodbye. Prints goodbye. So if we save this file and run it, now we're getting the output we expect. We're going to get hello world. We're going to get our middle stuff, 3, your name, and we're going to get goodbye, as opposed to previously where goodbye was printing after hello world, and then it printed 3 in your name. So we fixed one problem where now our code is movable. So instead of worrying about all this stuff that's underneath these functions, all we have to worry about are these function names. There's a very important call out here that I need to make, because this is another mistake I see happen all the time, where people get confused about why this doesn't work. So they put the names of their functions, and then they don't include parentheses after them. Watch what happens when I call this. Nothing's going to happen. Why is nothing happening? Because without parentheses, remember, this is like a tuple. You're passing values into it. So without parentheses, Python doesn't know you're trying to execute that function. It just sees this as, yep, you put a variable name there. Cool, good job. Nothing more. So you have to remember, if you're going to call a function, use your parentheses. Make sure that you're writing this correctly. And everything should work just fine. And that's really all you have to know for part 2 here. We're just kind of learning what a Python file looks like, how things are called, how functions are structured, and how this is much more manageable than typing everything into the interpreter. So stay tuned for part 3. All right, welcome to part 3 of day 1. So we're done learning what a Python program looks like and how you might run it. And we're on to setting up our Django project so we can put our Python code to work. Now, I want to be clear. This isn't a Django tutorial. I'm not going to teach you how to build a Django website and the best way to do it and all that sort of stuff. I'm going to show you how you can apply your Python code in the real world using something like Django. Now, we are going to build a fully functional Django application, and it will serve Python content to a browser, but it won't have things like CSS styling or JavaScript or really any fancy HTML, and we aren't using any plugins that you might normally use. So this is just to demonstrate how you might take your Python code to the next level. So in order to get started, we have to generate a Django application. Now you might be thinking, what didn't we do that day 0 when we ran Django admin start project config? Sort of. We created a project on day 0, and a project holds lots of applications. And a project has a couple special things about it. It has a config folder, which holds our settings.py, and those settings are like universal for all of your applications. And then a manage.py. And that's how you're going to run your application. So much like when we ran Python my program.py and we pressed enter, Python manage.py and pressing enter runs the Django application. But this is a project. It's not an app. We're not going to be able to add code to this. We're not going to be able to serve pages with this, that kind of stuff. So the first thing we have to do is actually build an application that can do that. Now, fortunately, Django has this command built in. So I'm on step number 2, Django admin start app my site. And this is going to generate a my site folder for us, much in the same way that Django admin start project config generated a config folder for us. And in the my site folder, you've got some things you haven't seen before. So under our config, you've got your settings.py, your URLs. Okay, we've seen those. But under my site, we've got a whole bunch of new files we can play with. We're going to focus on a few of them, but the first thing we have to do is change up our settings. So we've added an application my site, and that means we need to tell Django about our application my site. And so the first thing we're going to do is add my site to our installed apps. And we're going to do that on line 33 underneath installed apps. We're going to do that by typing my site, comma, and saving. So we're going to put my site underneath installed apps. These square braces, by the way, this is a list. So you'll remember from from part 1, we learned about tuples, which had stuff in them like this, 1, 2, 3. Okay, this is just a list which is very similar and holds multiple items in the same way with commas. Make sure you save settings.py, and then we're going to click on urls.py, and we're going to add some information here. So you don't really have to know what's going on here. You just kind of have to make your Django project work. So we're going to add include after path on line 17. So django.urls import path, comma, include. We're going to talk about importing a little bit later, but here all you have to know is that include is a special keyword, and we're going to make use of it in a second. Then the next thing that we're going to do, if I scroll down to instruction number 9, is add this path include my site URLs above admin. So I'm going to make a new line here, and I'm going to paste in from the tutorial. So path empty string include my site.urls. My site is the thing we just made, and it is actually referring to that folder. And it's referring to a file in that folder called URLs. In Python, when you refer to a file inside another Python file, by the way, you don't include the .py. So you can think of it like this. This is referencing mysite.urls.py. The .py is implied. So it's referencing urls.py inside our mysite folder. But you'll notice when we expand our mysite folder, there is no urls.py. So we've got some things we need to edit about this. But before we do that, we're going to make a templates folder. So you're going to right click on my site. You're going to click new folder. You're going to name it templates. Then you're going to right click the templates folder. You're going to click new folder again, and you're going to name it my site. This gets a little confusing because there's going to be a my site folder inside a templates folder inside another my site folder. Django merges all of the templates folders together if you have lots of applications, and this my site folder inside the templates folder helps keep everything for your my site application separate from other applications. It's not so important when we're doing what we're doing, where we're kind of like, keeping everything in one place. We're not going to generate another app, but I'm going to show you the standard anyway, so you don't make this mistake down the road. Then inside your templates my site folder, we're going to right click on that. We're going to make a new file, and we're going to call it index.html. This is our landing page for our site. So right now, if I run python manage.py run server, I'm actually going to get an error. But let me change back. You don't do this. Just watch me do this. So I'm going to comment out our mysite.urls, and I'm going to run this. So you're going to recognize this from day 0, right? So right now we go to localhost 8000, and it pulls up this install works successfully, congratulations page. That's all well and good, but we can't edit this page. So I'm trying to give us a page we can edit so I can show you some things you can do with Python code. And that is where this index.html comes from, because this is just an HTML page. This is the HTML page we're going to use to replace this page. So let's go ahead and do that now. There's some HTML I want you to copy in line for instruction 15. It just looks like this. If you know HTML, then you'll see this is all pretty familiar. We've got a doc type, HTML, and then we've got a body. This will look a little confusing. You might not have seen something like this before. But this is part of Django's templating language. The gist of it is we can pass Python data to an HTML template before it gets rendered in the browser. If you didn't quite understand what's going on there, I'm going to show you by the end of this day what it means. But understand we just need to make it look like this for now. So save this file, make sure you've got it named index.html, make sure it looks like this. Next thing we're going to do is open views.py. So a view in Django is a page, essentially. This over here is a view. Going to google.com and looking at the search box, that would be considered a view. Opening up your bank's login portal is a view, according to Django. They may not be written in Django, but in Django, that's what a view would be. So a view, having been called a view, so you're looking at something, is just a single page or a single function that shows you something useful or does something useful. And we're going to make an index view. So we have an index.html, and we want to show that on our browser. For that, we're going to need a view. So in step number 18, I have you write some Python code underneath create your views here. And it looks like this. This should look familiar from the beginning of today because we have a def, so we know we're building a function. We're calling our function index. And then inside the parentheses, we have an argument called request. We didn't talk a lot about arguments yet. We will later on, but this information will be available to any code underneath our function. Then under here, we're returning a function. So render, open parentheses, render is a special function, request, and then we're giving it mysite/index.html. So we're taking this request data, we're rendering something, we're returning that request, and then we're passing mysite/index.html into this function, and then we're adding some data in a dictionary. Now, we learned how dictionaries work because this is our definition or our key, and this is our value. This is our key, not our definition. This is our definition. And so I can access hello, the data here, by telling Python, hey, I want the stuff at data. Well, if we flip back over to our index.html, look at that. We're requesting something called data. That's probably going to be hello if I understand how dictionaries work correctly. So we're going to go ahead and save views.py. Now, I mentioned when we were building our config urls.py that we're referencing this thing called mysite.urls. And I said, well, this is actually urls.py, but if you look in mysite, again, there's no urls.py. We need to make one. Django doesn't do that for you. So let's right-click mysite, let's click new file, and then let's make a file called urls.py. There's not going to be anything in here, so I'm going to have you on line 21 of my instructions copy this Python code into urls.py in mysite. This is another instance where people will get confused because they'll see two urls.py. In VS Code, the reason this is so nice is because it's going to tell you this is the urls.py for my site, this is the urls.py for config. I will always tell you which urls.py I want you to be working in, and right now we're working in urls.py for my site. Always check your tab though. And the easiest way to figure this out, right, is urls.py and config has all this Django documentation on top of it. urls.my in my site, it's going to be pretty empty. That's okay. That's what we expect. Again, we're creating a list of URL patterns. And then here we're saying, okay, so at the empty string path, let's load up our function index. So views.index. Views referencing views.py. Again, we don't see a .py here because Python knows that's a .py. And index being our function that we've created. So we can just reference stuff like that from URL patterns. Okay, not much left to do but save that and then run our website. Python manage.py runs server in the terminal. Hopefully you shouldn't be getting any errors. If you do, double check to make sure you've saved everything. That's the most common issue is people forget to save their urls.py or their views.py or something, and they run the server and everything blows up. So make sure you've saved your files. Now, moment of truth. I'm going to come over to my browser on the right side, and I'm going to click the refresh button. And oh, there it is. We have a hello. We've removed our beautiful Django introduction page, and we've replaced it with our own Python data. And that's really, really cool because now we can write some Python code and we could potentially serve it to some users through a website. So moving into day 2, we're going to explore that a little further. But for now, that's the end of day 1. Thank you so much, and I will see you on day 2.